For our project, we investigated the tensile strength of sewing thread. We did an extended project and had two independent variables, the first being the degree of wetness of the thread, and the second being the diameter of the thread. Because we live in residence, we had to get a little bit creative. We balanced a broomstick across two trash cans to which we tied one end of the thread with a Nalgene water bottle tied to the other. We poured water into the bottle from a 400 milliliter beaker to increment the mass until the thread broke. When we increased the diameter of the thread, we ended up needing 3 bottles attached to each other to hold enough water to break the threads.
For our first independent variable, the y-axis is the force required to break the given thread in newtons. The x-axis is the degree of wetness, represented with 1 for the control variable of dry thread, 2 for the thread soaked for 1 second, and 3 for the thread soaked for 1 minute. The blue dots represent the force required to break the thread for all 10 trials for each wetness to show the spread of the data. The green triangles are the averages for each degree of wetness, and the green trend line shows a positive relationship between the average values, with an r-squared value close to 1, but, as you can see, more due to the difference between the dry thread and the thread soaked for 1 second than between the thread soaked for 1 second and the thread soaked for 1 minute. This is a brief summary of the average results obtained for the variable of wetness, and we are reporting the force with an uncertainty of plus or minus 0.245 newtons due to the fact that we incremented the mass in 0.025 kilograms and multiplied this by the acceleration due to gravity.
For the variable of the diameter, we increased the diameter of the threads by braiding 3, 4, and 5 threads together and doing 10 trials of each, using a single thread as the control. The data above shows a strong linear relationship between increasing the thread diameter and the force required to break it. You can see that the r-squared value is very close to 1, showing a near-perfect fit. Here is a brief summary of the results obtained for this variable, once again reporting the force with a 0.245 newtons of uncertainty.
Our uncertainties are due to the mass being added in 25 milliliter increments and the thread breaking in different locations. We tried to minimize these uncertainties by having 10 trials so that any outliers in the dataset wouldn't have as large of an effect on the average. We concluded that the force required to break wet thread is larger than the force required to break dry thread, but that the length of time that the thread is soaked in water has a negligible effect on that force. With the second independent variable, we concluded that as the diameter increases,